midpoint theorem. The line segment joining the midpoints of any two sides of a triangle is parallel to the third side and is equal to half of that third side. The line segment, here D is the line segment, D is the midpoint of one side of triangle AB, E is the midpoint of another side of a triangle AC. The line segment joining the midpoints of two sides of a triangle is parallel to the third side and is equal to half of this third side. This is the midpoint theorem. To prove this theorem, we need to do two steps. One is we have to prove triangle AED is congruent to CEF. AED, this triangle is congruent to CEF. We need to prove this first. Then we have to prove this DBCF is parallelogram. Once we prove this, this is parallelogram, then in parallelogram this side is equal to this side, that is DF is equal to becomes a BC. Once we prove this as a parallelogram, then rest becomes easy. Now they are given D is the midpoint of AB and E is the midpoint of AC. So join DE. Now the construction. Through C, draw CF parallel to AB. Draw CF parallel to AB and meeting D at F. So you have to draw this parallel up to F where it's going to meet D at F. This is the construction. Now we have to prove this triangle is congruent to this triangle. We know that this is the midpoint of AC, therefore length AE is equal to EC. And we also know that the vertically opposite angles, this angle is equal to this angle. Angle AED is equal to CEF because these two are vertically opposite angles. Here the angle EAD and ECF are equal because they are alternate interior angles, because AB is parallel to this and AC is a transverse. Alternate interior angles are equals. Here AED and ECF are alternate interior angles because AB is parallel to CF and AC is transversal. Therefore, because of angle, this angle is equal to this angle, this angle is equal to this angle, this side is equal to this side. Because of AAS axiom of congruence, these two triangles, that is AED triangle and ECF triangle, these two triangles are congruent. Because these two triangles are congruence, this side is equal to this side, then AD is equal to CF. AD is equal to CF. But because D is the midpoint of AB, then AD is equal to BD. Because AD is equal to CF and AD is equal to DB, therefore BD is equal to CF. BD is equal to CF and BD is parallel to CF. BD by construction, BD is AB is equal parallel to CF means BD is equal parallel to CF and BD is equal to CF because AD is equal to BD. Therefore, this DBCF is a parallelogram. Because DBCF is a parallelogram, then DE is parallel to BC. That means the first condition of midpoint theorem we have proved. That means that is a line segment joining the midpoints of any two sides of a triangle is parallel to the third side. Then D is parallel to BC because DBCF is a parallelogram. Then DE will be parallel to BC. Because these two AED and ECF are congruent, D is equal to EF. In these two triangles, this is equal to this, or DF is equal to BC. We can say that DE is equal to half of DF because this side is equal to this side. Then DE is equal to half of DF, but DF is equal to BC. DE is equal to half of DF, but DF is equal to BC. We can say that DE is equal to half of BC. This is the third side of a triangle. This is hence we have proved the midpoint theorem. First we proved DE is equal to BC. Next we proved DE is equal to half of BC. This is how we achieved. First we proved triangle AED is congruent to CF. Then we proved DBCF is a parallelogram. Once DBCF is a parallelogram, opposite sides of parallelogram equal, DF is equal to BC. Then DE is parallel to D, therefore D is parallel to BC. This is the first condition of midpoint theorem. Then D is equal to half of DF. We know that D is equal to half of DF, but DF is equal to BC. Hence we proved D is half of BC. These are the two things which is there in the midpoint theorem. That is, the line segment joining the midpoints of any two sides of a triangle is parallel to the third side. This is the third side. BC is the third side. Then D is parallel to the third side. D is equal to half of the third side. Hence we have proved. Let us summarize how we did it. The construction: C, extend, draw CE, CF parallel to AB, meeting D at F. Then prove this AED is congruent to ECF. Then because this is equal to this, and we because of these two triangles, this is equal to this, therefore this side is equal to this side. Because of that, this has become a parallelogram, and we know that these two sides are equal. We can say that D is equal to half of DF. Then half of DF is nothing but BC. Therefore D is equal to half of BC. Hence we have proved DE is parallel to BC and D is equal to half of BC, which is midpoint theorem.